Hey everyone! So I just want to tell you what to do for the Biotic Index Lab that you have due this week. You're going to need two things, and they're both on Moodle. There is a folder that says Resources for Biotic Indices Lab. And in that folder, there is the community data.pdf file, and there's also this worksheet, the macroinvertebrate index for biotic integrity worksheet. You'll need both of those, and then you will go to a Gradescope assignment to actually turn in your answers, which you can see here. This is what it looks like when you edit the questions, but this is what you will see when you get to that. So basically what you're going to do is you're going to go through this worksheet. And for each community, there are all these pictures of different invertebrates. Let me zoom out so you can see the whole thing. So this is stream 1. You can see there's 1, 2, 3, 4, 5, 6, 7, 8 different taxa here. You're going to need to classify them into these groups. There are 3 different streams, so you could either just take notes on a scratch piece of paper to figure this out, or you could copy this and type it in 3 different times, or you could print it out and write it in to do the math and figure this out. It's totally up to you. In Gradescope, you're just going to put the number in that's your answer. So however you want to do it, you don't have to turn in this worksheet part. This is what you'll use to figure it out. So you just need to write the number of species in each one of these blanks for each of the 3 streams. And do each one separately because you're going to calculate the index for biotic integrity separately. So basically what we're doing is somebody went out and they sampled a stream, and this is supposed to be what they found. And we're going to use what taxa of macroinvertebrates they found as a way to determine what the water quality of that stream is. We could go out and take water samples and measure nutrients or pesticides or the oxygen, but that would only tell us what those concentrations were at that one time point. The macroinvertebrates live in the stream all year long in some cases. In other cases, they're only there part of the year, but they're living for a longer period of time than we can take a water sample for. And so if the water quality characteristics are not good enough for them to survive, then we won't find them in the stream. And if that happened last week, they would have all died off if the conditions got really, really bad. So the idea is that invertebrates integrate all of this water quality information over a longer period of time, and the things that we find in the stream are indicative of what the water quality is like. You'll see that the index of biotic integrity, or IBI, that's what we're going to use by looking at the macroinvertebrates to see what the water quality is like. So they break all the macroinvertebrates into 3 different groups. Group 1 is the most sensitive, meaning that they need really pristine water quality, high quality streams. The middle quality group means that they can't handle really poor water quality, but they're relatively tolerant of some things. This says group 2. Group 3, is the most tolerant. I'll fix that on the one that you guys get. Group 3 is the most tolerant. Basically, they can live in very disturbed waters and do fine. And these are things typically that don't need high oxygenated water. So we have things like chironomids, which some of them are bright red, so they have hemoglobin to deal with low oxygen environments. Mosquitoes have air tubes, so they're actually breathing air. Some of the oligochaetes also have hemoglobin. And then these phycid snails, these are the lunged snails, they can come up and get air to breathe as well. All of the things in the most sensitive group, they all need really high oxygen and they need really high water quality. So basically what you're going to do is you need to write down the number of species in each of these groups. So if you find 2 Ephemeroptera, you write 2 here, and then you tally up all of these. And down here you're going to write the total number of species that are in group 1. You're going to do the same thing for group 2 and group 3. So you have total species. In group 1, you're going to take the total number of species, multiply it by 3, and put that number here. For group 2, you're going to multiply by 2, and group 3, you're going to multiply by 1. And then down here, you're going to total up the species richness, so you'll sum these total species for all 3 groups for the stream. The EPT richness, if you remember, I said there were 3 orders of insects that are really good water quality indicators. That's Ephemeroptera, Plecoptera, and Trichoptera, so EPT. So you're just going to sum the 3 numbers in these 3 blanks for here. And then the index of biotic integrity is when you add this number, and this number. So we're weighting the taxa by how sensitive they are to poor water quality. So this group 1, each one of them counts as 3 on this index, but the ones in the most tolerant group only count as 1. So you can see you're going to get a higher score if you have a lot of taxa that are in group 1. Now, in a really clean stream, you would expect there to be taxa in all 3 groups. The most tolerant ones doesn't mean they don't ever live in really clean streams. It just means we're going to get more of this group 1 in these really clean streams. So that'll give you the IBI, the Index of Biotic Integrity, and you can see you can interpret it here. The numbers between 0 and 10, it's a poor quality stream. 11 to 16, it's fair. 17 to 22, good, and over 23 is an excellent, very, very clean, very pristine stream. And so then you'll answer all these questions. So I'm going to have you list all the taxa for each stream, the EPT score, the IBI. You'll do that for stream 1, stream 2, and stream 3. And then finally, I just have a couple of questions for you to synthesize all of this information. And I have multiple points so that we can figure out where you went wrong if your IBI ends up being an incorrect number. So you do need to make sure you're identifying these properly. And a lot of them are at the order level, so it should be relatively straightforward. You guys have had a lot of practice with this. And then a week from this due date is going to be our lab practical. So you may want to take the time to look at some of these species more closely and practice families in some cases, though there may be a couple that we don't have the family of. I think a couple of these guys may not be a family that we included originally in the taxa you have to know, but you should know what order they're in. All right, so if you have any questions, please just let me know. I'm happy to help, and I hope you have fun with this.